All right, let's get this going. We are falling dreadfully behind in the terms of what we're doing here compared to what you guys are going to be doing at home. That's okay because we're having fun. Uh, I have heard from almost everybody. Actually, I want to say two pieces of business really quick. Um, I wrote some notes here. Uh, Several people submitted videos. The audio didn't work. Check your videos before you submit them. I don't know how to grade you if I can't hear what you're saying. It's kind of I can tell you made a video, but I don't know what it's about. Um, I also read the directions really carefully, guys. This video, you're supposed to respond to two students in your video or make two videos. It's a little ambiguous, but either one would have been fine. I'm going to be very forgiving about that. It's fine this time. Don't worry about it. But in the future, I have to knock some points off if you guys aren't reading the directions. It's just kind of the way it goes. It's good for you in the long run. Eat your vegetables. Um, and then last but not least, if you have a late video, if you didn't do a video because something crazy happened over the weekend, that's fine. Just email me a link to it so that I can grade it. Otherwise, you're gonna have a big zero on there. So pay attention to your grades, guys. You can figure this out. You can make sure that you succeed in this class. Uh, I think that's it. Does anybody have any questions about assignments, business, anything, any of that boring stuff? Cool. Okay. The other piece is I think that I've basically made my way through this list one time in terms of checking attendance and participation and all of that. Um, I want to make sure a couple of people. I need to call some names here because I have not. There's a couple of people on here, and maybe I have talked to you, but I just didn't write your name down. But if you're not here, I want to know about that too. Is Valeria in this class at all? You are here, Valeria. I haven't talked to you yet in this class. Do you have any thoughts from the last lecture? Any deep thoughts or reflections, or can you remind us anything at all that happened whatsoever? Right on. Yeah. I meant to spend more time dealing with astrology versus astronomy, but we're running dreadfully behind. So one thing, yeah. Has anybody else given any more thought to astrology versus astronomy? Yeah. Yeah. Well, there's something really tempting about the idea. This probably applies. I'll talk more about this next semester. I say that so much, but it's true that the surroundings, in some sense, the idea that bodies tend to remain in the state of motion that they're already in. So if you have a bowling ball floating in outer space, it's still pretty hard to move the bowling ball, which is weird because it's not necessarily bound by any gravitational system immediately. Um, that fact sort of implies that your connectivity to your surroundings in general matters. This is an idea called Mach's principle, named after Ernst Mach. You probably heard like the speed of sounds is like Mach 1, 2, 3, that kind of thing, maybe. But he basically pointed out like, hey, it seems like the whole universe is in some sense applying some sort of tension to bodies so they stay in place. And so the astrologers often point this out. And they're like, well, where the stars are matters in terms of where you're born. Um, it's not an outrageous proposal like from that physics standpoint. The problem is that the predictions often in one magazine are completely antithetical to the ones in a different magazine. And then like you brought up, uh, the actual date that your star calendar is supposed to be aligned with is like something like 2,000 years out of date at this point. Yeah.
There's a 13th sign as well, isn't there? And we
Okay,
kind of
you're out of my. Yeah, you're above my pay grade on this at this point.
so there's a 13th sign that completely got ignored so that it could fit with the Julian calendar.
Interesting.
Like
Interesting.
they were evenly distributed.
Yeah, I mean, in terms of like the planets themselves affecting you too, it's like the effect of gravity on you right now, compared to the effect of Jupiter on you right now, is something like a 60,000th of the amount of gravity that you feel from one body, with several orders of magnitude difference. So it's a difficult argument to make based on the bodies themselves. In terms of the arrangement of the whole universe at that moment of birth, like maybe. But the empirical, trials of this don't seem to play out. All right. Well, I'm glad I got to meet you, Valeria, right? Yeah, okay. Let me just keep going down here for right now. Is Lydia in this class still? No. Oh, you are. Oh, we've talked. Yeah, sorry, I just didn't mark you down. What about Ella Chaddock? We've talked a little bit. We've talked a fair amount. You've been here for sure, though. Any thoughts or reflections from last week?
Um,
Perhaps not as a language. Yeah.
them and the horizons and just how we um like make sense of like orient ourselves in our environments of where we are. Like connect that to inside and not to like the universe. Yeah, whatever.
Yeah, I think that the fact that it does seem like a sphere is going over your head, and that's actually a pretty accurate way of describing what's happening in the sky is kind of weird, because it's obviously not true from one perspective. I think that one of the stranger things about reality, the more the older you get, is that looking at things from different perspectives really does change how you view them. And so, I'm not a full-on relativist about any of these things, but there is something relatively true about the fact that a sphere is going over your head, and you can chop up the sky that way and still make pretty accurate predictions. And most people did that for most of history, from what I can tell. Nobody had, you know, very few people were under the conception that this is a rock spinning through space, from what I can tell, and that all of the things that are happening are also different forms of rocks or other bodies. Yeah, so that's kind of interesting and weird and relativistic and strange. Is Abigail in this class? Abigail, I don't think I've heard from you. What's going on? You've been hanging out? You've been having any thoughts? Mm.
One thing I was wondering is like, are there other than like those three that we know of, are like there are more types of planets? Or like are there types of planets that we just haven't discovered yet?
That's a really good question. Maybe we don't know what we don't know, first of all. One of the weird things we'll see when we start talking about exoplanets and stuff is that the big ones are vastly overrepresented, right? Makes sense. You see the big things, you don't see the small things. But yeah, it seems like planets kind of fall into basically the categories that we see in our solar system. These things that are called gas giants, which really aren't gaseous at all. We'll talk about that when we get to it. We have these ice giants, that's kind of a fair way of looking at it, like the Neptune things. See those all over the place too. And then, we don't see a lot of Earths or Rockies, but those are tiny little planets. They're really hard to see basically as a shadow on a sun, which is kind of how we detect a lot of these. So the huge looking Earths that are kind of smaller than Neptune's, but not quite. There's a lot of those that people see too. So I think in some sense it's a biased sample that favors the big things. But yeah, no other weird types of planets. Now there's bigger than Jupiter's. We talked about those too. Those are kind of interesting. Call them brown dwarfs because they're almost stars, but not quite. And we'll really play with the line between planet and star next semester. More advertisements for next semester. I just can't help myself. I really love talking about stars. Okay, cool. Um, well, I'm glad we got to talk. Um, Let me just make my way through this. Brendan, are you here? I don't have you marked down. Okay, we've talked. Yeah, you've been with it and participating. How about Lex? Lex, I don't think we've talked too much.
Yeah.
What do you have you been? You've been here.
Yeah.
You've been having thoughts.
Yeah, I feel like last class especially, when you showed the video of like around the galaxy, I thought that was really interesting, but that's just because like the idea of space in general actually really freaks me out a little. It's just so like massive and huge, and it's just hard for me to wrap my mind around. And so I like seeing the stuff like that. It kind of gets me outside my comfort zone, and I like thinking about it.
Well, it's pretty organized. That's what's weird, at least as far as we can tell, right? So, you know, you would think, maybe I think when you look up at the sky, you might think, oh, well, there's like a Milky Way over here. That's cool. But then it's just chaos and mad and like maybe that's why it freaks you out. Is it's just so big and we don't know what's happening. But what's kind of interesting about those cosmic filament studies that have been coming out is that it seems like there's structure even amongst all the big things, as best as we can tell. And so the order, these structures and order actually seem to persist. I don't know if that's comforting to you or not, but I find it kind of interesting. They also look a lot like neurons, which is really interesting. Okay, cool. Well, I'm glad we got to talk. You're right here in the front row. All right, I got two other people that I didn't hear from. Is Ashley in this class still? Ashley, I haven't heard from you, my friend. You been here?
Yeah, last week.
All right. We got any thoughts from last week?
Yes. Something that had stood out to me the last time was someone had asked you like the more instruments and like resources that people create does that kind of can that be able to like disprove like everything else that we have learned? And then you had responded and you said that it's not so much about disproving, but more about like if anything, just reassuring us that everything is correct.
I mean, it can be. That's kind of a yes and no question, right? So the question is like, if we build more sophisticated instruments, will they overturn our understanding of things? That's a yes and no. They don't have to, certainly. I think that, the persistence of there's been a lot of ideas over the years that have persisted despite having tons of data to the contrary. At the same time, it's absolutely possible that I gotta yeah, God, how do I do this without talking about stars? Stars are my favorite, most controversial things on Earth. There's a huge controversy with stars regarding whether they're made out of condensed matter or whether they're made out of gaseous plasma. Um, and anyways, I have a friend who he's very wealthy. I don't know if he's a billionaire, but he's a multimillionaire. And he's like seriously toying with creating satellites that he can throw at the sun to answer this question once and for all. So look, so sometimes you could actually do an experiment like that, right? Where you set out to solve a question and you build a new piece of technology to do it. So it's an either or. It's a yes and no situation. Okay, cool. And then Maritza. Yes, I haven't heard from you. You're the last person. This is amazing. I've actually accounted for every single person, I think. Any thoughts? You've been around? Did I miss somebody? Right on.
I think I talked about the workshop system. Like how there's like a video shield that's like hypothetical. I didn't know about that. I don't know how interesting. And then how like one atom can be like the difference between like elements of what type of planet it is.
Planet or star, yeah, I think was the example with the brown dwarf. The atom that broke the star's back. Yeah. Right on. Yeah, I wish I had more to say about the Oort cloud and the heliosheath, but they're very far away. We know very, very little about them, unfortunately. All right, well, it's good to meet you. Anybody? All right, so I'll open it up. I don't think I totally remember what we did last time. Somebody want to remind me where we left off? Is anybody awake enough to recall? I know where we should pick up again, but can't quite remember how we got there.
Maybe we finished on the work. We're just
Oh, we took a tour of the solar system, of the galaxy and everything. Yeah, I see. Any questions pop out at you? We've played a little bit with how slow light is, which is quite disturbing when you see it in that graphic. I always imagine 300,000 kilometers per second to be really fast, but then you imagine how long it takes for light to get from the sun, and it's kind of like, wow, light is actually pretty slow on the scales at which all these structures are existing. Yeah, Dante.
From the last class, it kind of, when you were talking and showed the video of how slow light traveled, it reminded me of when I learned about an old theory for how light could travel through space. When we didn't know about photons, we knew it was like a wave, and we knew all waves had to have mediums. So they proposed luminiferous alien.
Yeah. Oh, we're gonna be talking about that a bunch. Yeah.
and it's just stuff. There's just something that the light can go through.
Mm-hmm.
And then we just found out that it's actually both.
Well, we couldn't find it. Yeah, we couldn't find the ether. Yeah. Yeah, well, it's actually one of the great outstanding mysteries in physics, as far as I can tell, is exactly from a physical standpoint how atoms do light to one another. And so, yeah, for most of, let's say, most of the Enlightenment period up until about the border of the 20th century, people assumed that there was a fluid medium that was just really rarefied, this kind of misty ether in which the waves were occurring. But not only could they not find it, they built some really ingenious experiments that we'll talk about later. We're going to do a little section on light, so we'll deal with this in full. They also didn't know what the heck it would be doing, right? So in order to, like, a water wave is easy because the water goes up and down. Light's not quite so simple. So we'll come back to that, though. I'm glad you have some interest in that. Yeah.
That's kind of more just like a comment, like almost like a difference. I guess like when we watch that video, it seems like in like you can see almost how fast light is, just like if you turn on a light in a room or something like that. When we watched the video, it just made me think of like not like, oh wow, light is actually kind of slow. It just made me think like, wow, everything is like the universe is
So big.
Like,
So big.
so I feel like this is crazy.
So far away.
Yeah, so
Totally bananas, yeah. I mean, even you look at the moon at night and you're like, oh, it's right there. But it's like freaking, like, what, 60 Earth radii away or something? I mean, it's just insanely far away. It's just huge. Is that what it is? Yeah.
Every single planet.
I think it's more than that, actually.
In between Earth and the Moon, with
Oh, is that a fact? Yeah.
Pluto.
Yeah, it's unbelievable. It's actually, I find that to be kind of the most troubling part about studying, especially planetary sciences, is like just how difficult it is to access these points, right? I mean, you want to study another star system, even if you can go really, really fast, it's 5 light years or four and a half, something like that, light years to the nearest star system. And like, who knows if there's anything cool there or not? Maybe it's just a barren wasteland, and you got to move on to the next one. So I think this is kind of a theme that will keep cropping up, because if we're going to explore things that are really far away, we have to almost have these intergenerational projects to do it, right? You basically need to pack everything on the spaceship for another set of humans to come along and finish the job. I mean, these things are really, really far away. You can't travel at the speed of light. It's gonna take you 10,000 years to get to some of these places using the propulsion methods we have. So tricky situation. Okay. Cool, Isaac. Any other thoughts from the tour of the universe, or any of the other principles we were tracking up in? All right. Yeah. Anybody? Yeah.
I gets me thinking a lot about the Voyager expedition. Just sending off this piece of metal into space and having it float aimlessly throughout the solar system and eventually through the galaxy. And it definitely wasn't like the first thing that I expected the astronomers who launched it were things would happen. But it's become one of the reasons why we know so much about the outer planets, because we've gotten these photos from it. Say this is what it actually looks like from this angle.
Yeah, it's crazy. 50 years ago they sent this thing out, something like that? And it just keeps coming back and giving us more information.
Remember when we thought it died, like 2 years ago? They're like, it came back.
Just booted back up? Yeah. Yeah, so these are long-term projects. I mean, it's, what is it? Is it Voyager that just was it Voyager that just left the solar system, or was it Pioneer? One of
It would
these?
be Voyager 1. 'Cause
Voyager, yeah.
Voyager 2 got I think the photos of the planet. But
Okay.
outer planets.
Okay.
Voyager 1, we just sent out in one direction, like, go.
But it just got there, is my point, right? It's like, that's how far away it is. And this thing's moving at, I don't know, you guys can look it up, but thousands of kilometers per hour. I mean, it's really cruising as fast as you could get this spaceship going. And it just got to the edge of the solar system. So This is a big place and vast distances in between, which makes all the more reason why we understand things under our feet a lot better than anything else, and the things that are closest to the sun much better than things that are farther away. All right, cool. Any other thoughts on that? I'm gonna keep cruising. So, what I want to do today. So, I want to talk a little bit more about the ancient astronomers. I want to talk about uh, prehistory a little bit, and then the birth. We're really gonna start getting into the birth of modern astronomy, and the birth of mathematical physics, which is an interesting world. It's kind of the main paradigm we try to understand the natural universe in at this point, which is a good and a bad thing. But I want to talk about how that happened. So I thought it might be cool, actually. And perhaps important. I actually remember now. I left you guys with this anecdote. So we were talking about the celestial sphere, how to find the North Star. Obviously, the best way to find the North Star is the Big Dipper. You guys all see the Big Dipper? You should be able to see it at night, depending on where you're at. Um, and the Big Dipper, the tip of it's going to point you towards basically the back half of the Little Dipper, which is a little more difficult to see. But you basically get a sense of, you know, the North Star is kind of just off the coast of the Big Dipper's tip. And it turns out that that's been a really important asterism. So it's not a constellation technically. It's not big enough, I guess, is what it comes down to, but it's a sub-constellation. We call it an asterism. And so, yeah, it's great because if you know where the Big Dipper is, you can find the North Star. If you know where the North Star is, you can find your latitude. And in general, it's probably the most important star to pay attention to if you're trying to find your place in the world. Now, one thing I just want to put in front of you guys, and I'd be curious to I want to hear your ideas about this because I find it just completely fascinating, is the story that's been told about the Big Dipper. Uh, and I'll tell you some variations on that story that come from the Western tradition. So you guys all kind of know what I mean when I say the West. Anybody know what I'm talking about? Yeah.
Nations spawning from Greece and Rome.
Yeah. I basically think we all kind of live in the same civilization as ancient Greece at this point. It's a little different, but Rome was the next iteration of it. Medieval Europe was the next one. Colonial Europeans and America was the next iteration, and we'll see what comes next. But there's a tradition that goes all the way back to the Greeks. And it's probably a lot more nuanced and subtle than that. And we've, of course, incorporated all sorts of different cultures at this point. But what's really interesting is that the story that's told in the West about these involves these bears. There's like a little bear and a big bear. And it's kind of weird, first of all, that you would tell a story about a bear with this because, like, does it look like a bear to you guys? It doesn't look like a bear at all. So that's kind of interesting, first of all. And we can circle back on that. But for whatever reason, there's a story that was told. Now, the Greek version of the story was almost directly passed on to the Romans. The Romans changed the names a little bit, and they changed one kind of interesting feature, which I'll get to at the end. But the basic story is this story of Zeus, who's pursuing this nymph named Callisto, who's just, I don't know, this sort of like hot woods creature. He really wants her, can't get close to her. So he essentially disguises himself uh, as Hera. Excuse me, as Artemis. I'm trying to get the Greek versus the Roman names, which the Greek names are in parentheses. So he disguises himself as Artemis, who's kind of the deity that controls all the nymphs. And he essentially, has this intimate, deceptive interaction with the nymph. And then somewhere in the middle of this, as the deed is being done, the nymph realizes that it's actually Zeus and not her sort of matriarchal deity. And she's very disturbed, of course, because this is not supposed to happen. She's supposed to be a virgin, only in the service of Artemis, the woods deity. And this is really bad because Artemis finds out that her nymph princess has betrayed her, having consummated this affair with Zeus. And she basically, I want to make sure I get this right. She basically throws this nymph out of the group, kind of casts her out, banishes her, and turns her into a bear to have to wander through the forest. Now, this is quite tragic because the result of this affair that happened between Zeus and the nymph results in a son who turns out to be this incredible hunter, right? So it's sort of this double tragedy because the son is in effect hunting the bear. And then the story goes that, just before the son is about to, essentially kill the, the, the mother, Callisto, who's turned into a bear while hunting, she's transformed, like Zeus arrives and transforms her into, let's say, into the constellation, so she can live on as a bear in the constellation forever without getting killed by her son. Very convoluted story. Now, so that's the Greek version. What's kind of interesting is that the Romans basically take the exact same story, they change the names, and the one piece of it that they change is that the Zeus, essentially, in the first one, is the bad guy. In the second one, the reason this all happens is because Zeus's wife, this is Jupiter in the Roman tradition, Jupiter's wife essentially becomes jealous of the beauty of this nymph and sort of pushes him on to make this whole thing happen. But at the end of the day, why am I telling you this? Well, there's probably some sort of interesting wisdom encoded in this story. But what's really, really interesting is that the Iroquois Indians have a very similar story. The Lakota Indians have a very similar story. And the Algonquin stories have Indians, the Native Americans, they have a very similar story as well about this bear and being, pursued and put into the sky. So why is it that people keep telling these stories about bears and the constellations up in the sky? Anybody? Yeah. Yeah.
They would have been globalized at some point. I mean, a long time ago, perhaps in history.
Yeah. Yeah, I would have thought that was ridiculous until I discovered something recently, which is really quite interesting. So, yeah, maybe these people have, you could talk to yourself and be like, okay, well, people had to come to America. The story is that they came across this Bering Strait, right? Many, many, I don't know what it's at right now, 20,000 years ago or something like that. And maybe they had like some shared mythology at some point in time.
This is one thing that I had to study a lot about because I took a course on pseudo-archaeology.
There's a course on pseudo-archaeology.
There was.
All right.
At Ashland High School. It was fun.
Amazing.
Thing is, there's a lot of cases of human cultures that have no connection or relation to each other, having very similar stories.
There is.
But the immediate assumption to connect that to they must have had a global spanning single civilization that spanned the globe and somehow the Egyptians were connected and it just grows from that.
Yeah.
That was destroyed at the end of the last ice
Yeah.
is a good example of correlation doesn't equal causation.
It very well may be. Do you know about the haplogroup X, though? This is quite interesting. So there's this genetic variant called haplogroup X.
I did know. This is
It's
what
very, very strange, actually. This is very, very strange. So there's a genetic variant that is only found in the Mediterranean and essentially centered on the Great Lakes, where these tribes that I was mentioning are from. So it's just really weird. Like, so the standard explanation is that these guys came all the way across Asia about 20, 30,000 years ago. They somehow didn't leave any genetic traces as they crossed Asia and crossed Canada, and they end up on the Great Lakes.
That's what I was, yeah, because that was an old idea of like, well, they must have crossed over because it was based on an idea that they didn't have sea travel, so they couldn't cross the Atlantic, so they must have gone a different way. That's been disproven
Oh yeah,
for the most part.
I don't know.
There's an idea
There's a lot of people arguing about this one.
that it was mostly just from Mediterranean and then over to the east. It's because that's the shortest distance you could travel by boat.
Yeah, that would make a lot of
The
sense.
idea is they went north to Iceland, as
Yeah,
you can see,
yeah.
and then went down.
That is not the mainstream explanation for this.
That's the one I've seen.
But that makes sense to me.
That's the secondary explanation.
Yeah.
But
That's pretty crazy. If that's, I mean, I agree that that makes a lot of sense. I just wanted to show this to you guys. I don't claim to know the true answer, but it is an interesting piece of the puzzle, right? So you have these shared mythological roots. There's probably other pieces of this puzzle that are kind of weird. Certainly the Iroquois bear no immediate resemblance to the Mesopotamians, so this must have been a long, long time ago. But it's quite intriguing. It's an interesting piece of the puzzle, and you know, I do think that this is getting a lot more interest now than ever before. And it's interesting, you know, you mentioned like pseudo archaeology, and I think you've mentioned the word pseudoscience before too. It's a really, really interesting slur of a word is the problem, because things that are often considered pseudo whatever turn out to be correct later. A good example is plate tectonics, right? This was complete fringe heretical science when Wegener first proposed it in the 1950s. Everybody was calling him all of these terrible slurs at the time.
the difference is his was based on evidence.
Yeah.
Actual empirical evidence.
Well, it's often
Modern pseudo-archaeology.
well, they were still calling him. They were still calling him a pseudo geologist at the time. Yeah, he was getting all of the same terms applied to him. I guess, like in some sense, some of this, let's say, immune response to wacky out of the box ideas, I think, is warranted in some senses. I think that a lot of guys who have been pushing some of these ideas, like Graham Hancock, stuff like that, right? They might actually have some good ideas, but I think they overrepresent the certainty of their arguments in many cases, right? They're like, this definitely happened, right? And like I keep saying about this entire project of science, like a huge value that we have is that we don't claim these kinds of certainties with our theories, right? We're always open to the idea that maybe there's a different, better explanation for this data. Yeah.
The biggest thing I learned in that class was the difference was like people like Grant Hancock started with they had a conclusion and they wanted to find evidence that proved it.
Yeah, absolutely.
That led them to conduct bad science.
And that's how, unfortunately, that's how a lot of mainstream science is done too.
Grift, as he called it. He didn't come in with that idea. He just was looking at maps, looking at the world, and thought that, well, South America looks like Africa. And as he kept looking, he kept finding those things, and that's where he drew his conclusion.
I think that's what Graham does too, to be honest with you. And honestly, I think a lot of people go and design. I mean, I've been in the top halls of every single, and I've known a lot of people who've done very well reputed mainstream science who also have conclusions going into their experiments. So I think it's in some sense a political term that's designed to, cut people out of the discussion, and I don't like that. That's not to say that I think that these people don't bring it on themselves in some sense. Like I said, I think Graham does a really terrible job of overrepresenting the certainty of his claims. But I fundamentally resent casting people out of a discussion just because you think their idea is bad. Sometimes some of the worst ideas turn out to be true. And I think, Darwin's a great example of that. Copernicus is a great example of that. They go on and on and on. So, anyways, I just wanted to throw this guys in front of you. I've just been thinking about it a lot. I think it's really, really interesting. Now, if you go around the world and you actually look at this same representation in other cultures, you actually don't see bears everywhere, which makes it even more interesting. You would think, okay, well, maybe everybody on Earth tells a bear story about the North Star, or about the revolving dippers, but it's not the case. So, in India, they tell a story about the 7 sages. In China and Japan, they tell a story about the god of war. We got the 7 stars of the north in Korea. We got the Finnish, they actually see it as a salmon weir. Do you guys even know what a salmon weir is? I guess it's like some sort of trap that you catch salmon at. I have no idea. I've never seen one before. There's a lobster in, I believe this is in Burma. Yeah, in Burma, there's a lobster. So my point is that people see lots of different things with these pole stars, but the bear persists in the Western tradition, and it does persist in some of those Great Lakes indigenous traditions too. So pretty bizarre and weird. I just thought I'd share it with you. I think it's interesting. I've been thinking the haplogroup X stuff is pretty bizarre too. Again, who knows? Maybe maybe we'll find some more material artifacts that will make us make sense of this whole picture of what was happening 30,000 years ago during the peopling of the Americas. That's there's certainly very, very little evidence of what was happening with people in America 20,000 years ago. It's like a couple footprints and maybe like some arrowheads or something. It's really sparse. Yeah.
You say the pole stars, are you referring to like the North Pole or the Big Dipper?
Yeah, so remember the pole stars do change over time too, so it's weird. There's 3 of them technically, and people are still trying to make sense. But right now, the most popular theory is that the Earth's tilted, but it wobbles a little bit, and so it points at a different pole star every few thousand years.
I don't want to get like too off topic or anything, but so with that idea, like the pole star changing, would that mean that there's periods of time where like it's not really pointing north?
Yeah, it's not perfect. It's not perfect. Absolutely. We'll come back to that too, because we're gonna look very carefully at the theory, as it relates. It's kind of tied up also in the story of the glaciation cycles, which is pretty bizarre. But I think there's a lot of work to be done on both those theories, to be honest with you. The closer you look at them, the more questions arise. Yeah.
I don't think it would ever really be perfect.
Yeah.
It's certainly exceptionally useful for navigation. Even if it's not perfect, it's only a little bit off, so it will still be very useful for getting your bearings.
Absolutely. Yeah, it's close enough for jazz. And I think it worked for people in the past really, really well. People, I think I mentioned this last class, but I don't know. There's I have like a little castle of interesting points, and sometimes you guys got to stop me if I've already told you this, but the height of maritime navigation was like 1500 BC. Like most archaeologists will agree that like people were way better and had more extensive trade routes in 1500 BC than they did all the way up until the colonial period of Europe, essentially. That's pretty weird too. So like people were getting around, they knew how to move. And they kind of rediscovered that it was a really gnarly dark ages, at least in the Western tradition, for the first millennium or so.
I'd actually read kind of about that and like took those responses because I was wondering like if the pole star was like not off, like whatever happens when the pole star is changing, if that could explain why like the height.
Why people got bad at it?
Yeah, why they got
That's interesting. I like that. That's a cool theory. I don't know. Probably multifactorial. I mean, yeah. I mean, you had the fall of Rome and all that. It's
Today,
what's that?
the fallout of which we still feel today.
Yeah, the continued fall of Rome.
Never forget that those 2 were almost entirely the result of the fall of Rome.
Yeah, well, yeah, it's where do you want to go? That's the funny thing. Like Dante and I were talking after class last time. It's like you want to talk about some historic events, you try to trace it back to the beginning, and you find yourself, well, should we keep going back? All of history is kind of like one continuous chain of events. It's hard to really figure out where anything starts. Okay, so anyways, I thought that was fun. So this is how people were looking at the stars a long time ago. We'll circle back on some of that. Now, since I've been, in some sense, kicking on mathematics and being a little bit irreverent about all these, I thought I would tell you guys a quick story about sort of the foundation of mathematical astronomy and mathematical physics. And we're going to work towards understanding how orbits are defined and some of the work of Newton and Kepler. But this story is kind of interesting. I can't remember if this is in your textbook. It might be, but I think that it's worth us discussing anyways. So there's this dude his name's Aristophanes. This is in like the 1st century BC, I believe. No, somewhere in the 1st millennium BC, so first 1,000 years BC. He's in Hellenized Egypt. So Egypt was taken over by the Greeks at some point. And this is where Alexandria was, the big library, you might have heard about it. I think it was like a huge university town. You could think of it as, gosh, I don't know, kind of like Cambridge, Massachusetts, where all the colleges are at, and Harvard and everything, MIT, something like that. And he was a scholar working there. And, the apocryphal story is that they had some sort of timekeeping system in this day. I want to say it was probably something like a water clock where some amount of water drains at a predictable rate, and they can kind of keep track of time this way. Maybe it was an hourglass, same kind of thing. And he was doing some sort of surveying or something, and he noticed that there was a well in this one town that he was visiting, and he noticed that where he was normally at in Alexandria, there was perhaps, and I might be switching these two towns, it doesn't matter. One town, he noticed that at high noon, there was no shadow being cast, let's say, on this pillar, right? But over at this other town, when it was high noon, well, let's go the other way around. At high noon, let's say in Syene over here, when the sun shone exactly down inside of this well, so it illuminated the bottom of the well, it did this like somewhat before noon, let's say, right? But at the same time, let's say this was like 11:50 or something, back in Alexandria, it did not actually cast zero shadow over top of this pillar that was near his university or whatever. This is weird, right? Because there's a difference in the shadow effect, right? You would expect that, at the same time of day, you would essentially have, noon is when the sun is directly overhead, right? Well, this wasn't what he saw. And he reasoned, story goes, and of course, the reality of this story, by the way, is that it might be like 40 different guys all working together in different places who all kind of stumbled upon this at the same time. But we're left with the story of Aristophanes. He basically reasoned that the sun was really, really far away, and it's shining its light on the earth. And if the earth is actually this rounded ball, which, like I said last time, there seems like there was some whisperings in the ancient world that the earth was a rounded ball of some sort. The Indian word, for instance, for the earth seems something like ball of mud or something like that. So he had this suspicion that the earth was this rounded ball, and he thought, if the light's coming in and it's really, really far away, the rays are essentially parallel, well, then we could actually get some information about the shape and size of this thing based on the way that the light hits this pole at noon, essentially, several miles away from this other site where it's shining directly into the bottom of the well. And it's basically like 7th grade geometry that he's using here, and it's pretty brilliant. And I think this is like just a real remarkable piece of math, right? So if the shadow casts by this pole, you could basically measure an angle at which that shadow is cast from the top of the pole, right? And if you extend the line of that well all the way to the center of the earth, you could also theoretically extend the line from the well to the center of the earth. And then since you know from basic study of the most simple geometry imaginable that these two triangles fit together perfectly, that means that these angles are identical, right? You maybe heard like opposite interior angles are always identical. It's like something you learn in 7th grade and you're like, yeah, whatever, that makes sense. They knew that. And they essentially used that to figure out what angles separated these two towns from each other in terms of the globe itself. Pretty smart. And the result of that is that they kind of could measure, in whatever way they did back then, they measured the distance between these two towns, and they knew that that was something like a 50th of the entire globe. So they just extend the distance of that, and they essentially come up with a measurement of the Earth that, from all accounts, seemed pretty darn close to the real value that we use today. To walk it out? Amazing, yeah. Maybe he paid him. Maybe he whipped him, who knows? Yeah, I'm sure it wasn't pretty. Yeah, these are thousands of years old stories. Who knows if they actually happen? They usually are inherited from different, some philosopher told some other philosopher told some other philosopher. So I don't know if this actually happened, but it's a cool story, and it kind of sets out this project of mathematical astronomy, right, and mathematical science in general, mathematical physics as a huge project that can do wonders, right? We can answer this question of like, how far around is this planet? It's just a question that maybe lots of kids in that day asked, but everybody was just like, that's a stupid question because we'll never be able to answer it. And they answered it. And that's really, really cool. So this kind of sets the entire project in a good light. So I basically walked you guys through that already. Now, the Greeks got stuck beyond the sphere of the Earth itself. So, one thing that really troubled them and really set up this bizarre paradigm where the Earth is at the center of the universe is that they noticed that most of the stars, with the exception of the planets, which we'll get back to, most of the stars seem like they're always in the same place. So, have you guys, let me do this example right now. If you let's say, put your finger out far away from you and look at it and close one eye and then close the other, right? Now bring it really close to you and do the same thing. You can see the finger actually moves a lot more when it's close to you, right? When you have it, the further you move it away, the less it moves when you close one eye and then the other, right? So this is called parallax, right? The basic idea is there's a triangle set up between your two eyes and the finger, or whatever you're looking at. This is how we get depth perception, because you kind of put together these two angles and you can actually get a sense of how far away it is. Your brain does these calculations without you having to think about it. Thank God for that. But the paradigm that we all accept more or less today, the one that we're operating under, at least for the duration of this class, is that the stars are really, really far away. They're essentially like your finger over there. You can go to two different places on Earth and point a telescope, and they're so far away that you're not going to see a parallax effect, essentially. In fact, you can be on one side of your orbit, say March in the Northern Hemisphere, and you can wait all the way until it's October in the Northern Hemisphere, and the parallax that you'll measure is so small that these ancient astronomers had no chance of seeing it. So they figured, any arguments that the Earth was going around the sun were ridiculous, because if it was, you should at least be able to see some sort of parallax effects across a season, and they couldn't see them. So that set the entire project of astronomy on a really wacky course, right? So again, this is one of those cases, Dante, where the evidence that they're pointing to, solid evidence, right? But there's some sort of misunderstanding about it. I think they couldn't conceive that the stars were 4, 5, 10, 20, 100 light years away. I think those distances were just completely beyond their imagination. And so they assumed this whole sphere, just like we studied last week, is just going around us, basically. That was the only thing that made sense to them, given this lack of parallax. And all the best philosophers of the day, Aristotle on down, championed this notion. There was some dissenting pseudoscience back then as well. These navigators would come back from their sea journeys, and they would say stuff like, "Hey, we see actually different stars like down here. Maybe there is some sort of effects of location, and maybe we are actually going around the sun." Um, there was uh, there was later some dissent in Islam as well, but this is like 1,000 years later. So there was some dissent along the way. The phases of the moon also gave people pause too, because trying to understand why the moon is doing this very predictable phase thing. Well, if it's going around the Earth, that's one thing. But what about other planets, right? So uh, there's reports of Venus having phases as well. Have any of you guys ever seen the phases of Venus before? So there's people, at least people. There's a population of people who claim they can see it with the naked eye. I can't personally, but I don't have great eyes. I can definitely see it with a sighting scope or binoculars or something like that. Um, so there was some whispers of maybe people could see the phases of Venus, and of course the phases come from orbiting around a body. If Venus has phases, well then it's definitely orbiting the sun, and that changes the entire platform. So there was a lot of people who were kind of making these arguments, but they couldn't substantiate them very well, and it was just this argument kind of laid in the background for a very, very long time. Um, Now, talked about Ptolemy at the beginning of this course, I think a little bit, because I was kind of pointing to a mathematical model. I thought I'd actually just illuminate that a little bit. I know there's a section in your textbook, but it's worth pointing out. Um, One of the biggest problems with the Earth being at the center, right? With this, everything kind of makes sense. Most of the stars are spinning around your head. Earth is at the center of the universe. You can do it. The planets are a problem, though. And in particular, not just most of the planets, but Mars is a really, really big problem. Now, why is that? Well, we understand today that Mars is kind of outside of us on the solar system a little bit, and we move a little faster than it. So you could see Mars rising over here one day, and then at some point we actually overtake it, as the year progresses, and we kind of get out in front of it. The result of this is that Mars appears to actually go backwards in the sky at some points, and this was super confusing to the people who were working with this geocentric model. Now, just because it was confusing didn't mean they didn't have an explanation. And this is something humans are really, really good at, right? Really, really good at arguing our way out of things. Especially if we're super genius eggheads, we can dig our way out of almost any problem. I always tell this to people. It's like, any of you guys married? Like long-term romantic problems? Or partners? Not problems. Freudian slip. I love my wife. But I will say, the worst thing that you want to do when you get in an argument with your spouse or your significant other or whatever is be right. Like you don't actually want to win an argument. That's not a good thing. Like just because you can win an argument doesn't mean you should, because you don't want to be married to a loser, first of all. So you don't really want to beat your significant other down, right? And make them say uncle or whatever. That's not kind of the relationship you want to actually have. But also, just because you can win an argument doesn't make you right. And that's kind of the difficult situation of this. So these guys had concocted an elaborate system of different, let me see if I got a picture of it. Here we go. They basically had created these orbits on top of orbits, right? They call these things epicycles, where they basically find a way that Mars could be dancing backwards while still moving forwards in its general orbit about the Earth. And again, the precision, the mathematical certainty was top notch. The evidence was solid, but it's not how we think about it anymore. And in some sense, the way that we thought about it changed rather slowly, actually. By the way, here's a good comparison of the two different orbits. So this was kind of what they were imagining Mars doing in one, in the Ptolemaic model versus ours. Now, people, by the way, at the time they argued that this is far more beautiful because it actually traces out this beautiful trochoidal pattern. You can imagine kind of rotating that all the way around. Maybe you guys played with these like stencil type things at some point. You get these really beautiful floral patterns. And they thought that, first of all, this has perfect circles involved. It results in these beautiful floral patterns. This is what God would have wanted for sure. And so they went with it. And it was very, very, very difficult for people to dig their way out of this. One thing that's kind of interesting, yeah.
Notice that at some points the orbits like kind of overlap. The geocentric. That's the geocentric, right?
The one with the blue thing at the center, yeah.
Yeah. Was it ever talked about like the idea of the planet being like consumed by the sun?
I think that the sun stays at a reasonable similar distance. I think that Mars manages to get out of the way of the sun just in time every time. I don't know that was like a particular objection.
Because you can see it's pretty close, and I'd assume that
It does in that picture anyways. I'm not sure how accurate that picture is either. But they're also very, very, very tiny, right, compared to these things. So yeah. Yeah. Yeah.
the point still stands.
Yeah.
That was taken into consideration, like the idea of it, like false.
Yeah. I mean, it was very, very solidly predictive. I actually know a guy. I met a guy. I did a podcast with him. It's completely insane, but he has created a model of the solar system using all of NASA's data, where he still argues that some version of this system is actually more correct than the one that we have. And his mathematical arguments are solid. I will tell you that much. I don't think he's right for other reasons, but it's shocking to me how easy it is to argue for two perspectives based on some pattern fitting to what you see. It's very, very interesting. Yeah.
One thing that is always fun when dealing with like science or pseudoscience is often math. You can math, like you say, you can math anything to fix any problem.
If you're a really good mathematician, for sure.
It's a man-made human invention.
Yeah, it's a tool. Yeah.
But you can't just so easily dispel what you see with your eyes. Ultimately, you can have all this complex math, but what trumped, Ptolemy's entire model was just a way to see better. It's just glass that could see farther into the sky.
I think that the glass helped a lot, but Copernicus came up with this before the glass, which is quite interesting, right? So Copernicus was not happy with that model, first of all, before, and I don't have a ton of insight, and I would like to actually try to read more of Copernicus's letters. So Copernicus was a really, really fascinating dude. So this was in 1543, where he actually published his manuscript that had the argument for the kind of not so perfect, but heliocentric cosmos. That was actually the year he died too. So Copernicus was a really interesting dude because he spent his whole life carrying this manuscript. Like he wrote it when he was like in his 30s. He carried it around with him in his like breast pocket, and he would, at least the story goes that he would like, only share it with his closest friends, because he realized that it sounded insane. This was complete pseudoscience in his day, right? You don't. What are you talking about? Like the guys over at Harvard, whatever it was at the time, Oxford or whatever, they've the church. Well, yeah, this whole academy thing stemmed from essentially the monastery system. Before that, we had Alexandria and on and on. Anyways, the experts have looked at this, they've figured it out. What are you doing? What are you talking about? They've already fixed this. The stars don't have parallax. What are you talking about, Copernicus, right? So he waited his entire life essentially to publish this thing. His actual profession, I believe he was a physician. He worked in some of the local city council type stuff along the years, but he was fortunate that the printing press was essentially coming out at the end of his life, and so he was able to actually print this thing. Like I said, the year he died, and began to become distributed. Galileo comes along. Galileo's a little bit of a, what would we call him? Almost like an influencer type guy. He's kind of always trolling people. He does experiments. He's a scientist and a thinker as well. But he really likes Copernicus' idea. He reads the book, he likes it, and he decides that he's going to start trolling the Pope about it, actually. So, again, two very different approaches to bringing a new idea into the world. Copernicus, very careful, slaves over his manuscript his whole life. Eventually, he's about to die. He's like, I should probably publish this. It's too late for me, anyways. Galileo, he actually writes his defense of this heliocentric system by way of a comic play that he writes. It's, I guess, just a little novel. It's essentially called, I think it's called A Dialogue Between Two Worldviews. But he basically makes the Pope one of the characters in this story. He names him Simplicus, which basically means idiot, and makes the Pope look like just like a complete moron in this book. Predictably, the Pope essentially, all but has him executed, right? He puts him on house arrest for the rest of his life, makes sure that the book will never be published, and kind of defangs Galileo for the remainder of his career. So, this kind of gets back to what we were talking about at the beginning of class. We were talking about Graham Hancock and stuff like this, right? From where I'm sitting, the way that Graham Hancock goes about pursuing his scientific ideas, you can love him or hate him, but I think he's a little more like Galileo. I think he kind of trolls the Pope a little bit in this sense. I think he's kind of over the top. I think guys like Wegener were actually, and we'll talk about Wegener, and we'll talk about Wegener versus Carey, and there's a whole story there. I think guys like Copernicus, guys like Darwin, Wegener, I think that they have a much, much, much greater respect for the authorities that they're dealing with in some sense, and they're more careful about it. Yeah.
I see Hancock as the church in a similar way that his ideas, his in the misunderstanding that like the Greeks had, right, stemmed from sort of his denial, like the denial of how could of just his own might say religious beliefs or whatnot conflicting with the evidence, conflicting what is being shown with his eyes or the evidence is just it can't be because how could because it all
Well, I think by church, I think by yeah, I think by church I'm referring to like the authority structures of the day in that point in time. Graham is certainly not an authority structure today. He's definitely like on the margins. Whether he's right or wrong, I'm not even like really trying to get into that necessarily, because we'd have to like pick out individual things that he says and try to like see what are you talking about? Is there what's up with this argument? My point is that he's more on the Galileo side of the way that he approaches bringing these ideas to light. It's much more of a trolling kind of like bombastic, like, no, this is definitely what happened. There's these crazy people, there's big world civilization, and it's like, maybe the civilization was more extended than mainstream archaeology gives it credit for. I don't know. Maybe it was, but I don't think that it was like some super high tech like thing where they got flying hoverboards and iPhones and stuff either, right? And he can kind of come across like that's what he's saying is absolutely what the evidence is pointing to, which is just reminds me of the way that Galileo would have talked about things in his day and what kind of got him in trouble as well. So I don't know. The reason I'm trying to talk to you about these things is because I think that there is a human element to introducing new ideas, to looking at things differently. It's not enough to just see something brilliant. I mean, I think anybody who's had a real scientific revelation in their life, who's really seen the world differently and then been like, oh my goodness, I think I might be right about this. I think at first they're excited because they understand something nobody's ever understood. But I think that the rest of their life is kind of like, oh man, I wish I hadn't seen this because it's nobody wants to hear this. Everybody's really happy with the story that they already have, and it's really going to be quite painful for me to try to bring this into existence. And so that's a picture I have seen over and over again in people I know who have tried to change different paradigms. And some of them have done it successfully, but it often takes their whole life, and it's quite a difficult job because there is this human element. There are authority structures who really do have narratives nailed down, and they're not particularly interested in changing the way that they've been thinking about these things. Right. So, two ways to buck the system, I suppose. So that's Copernicus. Galileo. We talked about Galileo a little bit. Now, Galileo did have one thing that I think he did in the end sort of win the battle, despite the fact that the Pope cut him down. He had a telescope. He was one of the first. He was, as far as we can tell, he was the first person to take a telescope and point it at the sky, which is pretty bizarre because the telescope had been around for a little while. Dutch navigators had been, the Dutch were famous for lens grinding. They made glasses. And it wasn't long before somebody decided, hey, if we put two of these lenses in a row, we can see far away. And so, for whatever reason, Galileo gets a hold of one of these telescopes and starts pointing it at the sky. And lo and behold, he sees a couple of things that, make Copernicus's argument quite irrefutable. He sees those phases of Venus, right? In other words, Venus seems to be orbiting the sun. That's not good for the geocentric model. And he also sees moons around Jupiter, right? And that's not good either because everything's supposed to be orbiting the Earth in the church's view of the day. So I think that's also, this is another question. Does the technology sometimes revolutionize stuff? Yeah, absolutely. Like it absolutely does. But there's usually an argument that it's reinforcing one way or the other at the end of the day. And people, had already been entertaining this idea that maybe the Earth isn't at the center of the universe. They'd already kind of been there for a while. And so the new technology comes online, and the story changes very slowly, but it does change. There's his actual telescope. Look at that. All right. So, who's the church today? Yeah.
Science, probably like just the entire academic science industry.
Yeah, I'd say like state science. Yeah. In some sense, NASA maybe. What do you think?
The church.
The church itself? They don't have a ton of power. Like the religious church. I mean,
They have enough.
there's so many different churches, and yeah, I'm more talking about who controls the scientific narratives of our day. I guess who's the authority today, right? Maybe you could say consensus of different high-ranking journals, something like that. Yeah, yeah. I think that the government pays for a lot of this, in some sense. I mean, look, if you're a scientist, we talked about this at the beginning of the course a little bit, but where do you get money? You got to ask these granting institutions for money. You got to ask the government for money. Um, you know, there's some seat of power with respect to the approaches that are taken. Let me trying to think of some super far out idea. I'm not going to be able to ask. Okay, so if I was talking about condensed matter and the stars earlier, which is a really interesting topic. Maybe we'll have time to preview that in this course at some point. But let's say I want to design an experiment, like my friend Jim, who wants to build satellites to throw at the sun. Can he go and ask a scientific body for that? Well, he could. He could go to the NSF and say, I want a grant to go see if the surface of the sun is condensed matter. And they would probably say, that's stupid. We already know the sun isn't condensed matter. We know that it's gaseous plasma for this, that, and the other reason. And that's pretty much where that project would end if you're depending upon some sort of state body to give you funding to do it. So I think there is still some analog of the church in our picture today. It's probably more about who gives you money and whether the journals will entertain publishing your crazy ideas or not. But it's certainly something we wrestle with still. So, I think that there's a lesson to be learned here about the difference between Copernicus and Galileo, and how you approach authority structures and how careful you are and how much certainty you claim when you want to change people's minds about things. What do you guys think? Any thoughts on this paradigm? Yeah.
It's interesting to think about. We keep saying they and the authorities and all that stuff. But in the end, it comes down to maybe a handful of people in a room arguing over a thing.
Yeah, or not arguing, maybe just dismissing it outright too. I don't think the church guys really were arguing. I think they were just like, this is stupid. We know it's stupid. People have been telling, all the greatest scholars for the last 1,000 years already solved this problem. Like, get this guy out of here. Yeah, I think a lot of that is that's the hardest, that's the inertia that I think is hardest to fight on a lot of things. And I think that's a blind spot that people are kind of shocked to discover in themselves. Yeah.
The textbook kind of mentioned this, but often uh, information or the truth is obscured for political gain. Nations, I mean, we all know the term propaganda. It's something as old as human civilization has existed.
Yeah.
And the main thing that separates mainstream science from the church is that mainstream science has the goal of genuinely trying to understand the world and spread the act what is then understood true. Is there inertia in changing their minds? Absolutely. But they don't. But even if the truth was discovered or known at the time of the church, they had every reason to deny it, even though they knew it was wrong, because they had already been doing it. They had every reason to keep doing it.
Yeah.
Because they knew.
Yeah.
The moment that the geocentric model was lost,
Yeah.
faith in their power and what they said
Yeah.
would be lost.
Yeah.
And that's exactly what happened after the geocentric model.
Yeah. I
Protestant Reformation.
Not just faith in their power. You're talking about an entity whose entire infrastructure based on infallibility, especially at that time in history.
yeah.
And as soon as they claim, "Oh, we were wrong,"
Yeah.
it severs their
Yeah.
I mean, what if I told you that there was a misunderstanding about something at the heart of a scientific discipline that, if it was actually understood, would completely undermine an entire body of knowledge, say 100 years worth of papers.
But that kind of thing is almost celebrated in science in a way that was never.
Not if you're one of those guys who writes the other kind of papers.
Because
Yeah, I mean, I look, I would have thought that too when I was your age. I would have thought that for sure.
I know there's money.
It's not even just money, man. It's just people's lives dedicated to worldviews. It's like, and a lot of this can happen subconsciously too. It's not necessarily some guy who's like, I'm gonna obscure the truth. It's more that people become committed to one way of seeing things. Uh, Absolutely,
Yeah,
it is.
exactly.
It's absolutely a crisis of faith. If you guys, again, if we stick around until next semester, I want to talk about stars a little bit, because if we misunderstand something very fundamental that I think I can prove to you in about 5 minutes to be a mistake, it really does undermine a tremendous amount of work by people who are very brilliant and have done incredible mathematical works equivalent to the Ptolemaic epicycles. And those people aren't going to go down easy. It's not going to be a simple thing. And so I think this happens. This is a normal thing that humans do when we try to understand the universe. We get really, really proud of ourselves for having figured things out. I think this kind of stuff is brilliant. I mean, this guy was right. This was 2,000 years ago. This is a good idea. This is a really cool experiment. But then the tradition from which is birthed from this follows this same sort of platform for how to understand the cosmos and gets it completely wrong. And they get entrenched, and people are, you know, excommunicated from the community, and like careers are ruined. And I'm afraid this is something that we do, and I think it does still happen. I don't think we're protected from it just because we've been so successful in many ways. We have a lot of success stories today like this. There's a lot of things that are absolutely, no doubt, going to stand the test of time. There's other ones that are hiding in plain sight that might not be, which I think is actually quite exciting. But it's easy to be blinded to it because we always, as human beings, think that we're a little bit smarter and wiser than the people who came before us. And I'm not sure that it's quite such a linear progression. Yeah.
I think an important thing to note is that faith shouldn't be only applied to the traditional religions, but we have, as a society, have placed an incredible amount of faith in our scientific method and its conclusions. We believe in them with the same fervor that some would be believing the church in times past.
That's absolutely right. Yeah.
We've got that same level of faith and belief in it. It is absolutely right. We truly believe it's right, regardless of any new counter evidence, until we have the next revolution of thought.
Yeah, and it really does take revolutions of thought is the problem. I mean, and look, Graham Hancock's just as guilty. He's got absolute faith in the validity of his theories. I don't think you could talk him out of it with any arguments. But I think that I think that it happens all over the place, I guess is my point. It can happen to really smart people. I met really, really smart people that I see captured by their faith and ideas. Um, I just think there's something really healthy. And actually the big, $10 word for this is epistemic humility. This is sort of like having some humility about the way that we acquire knowledge, right?
I think a part of it is, I mean, like in the last 5 years, I've noticed a significantly declining faith in science, specifically medical science.
Well, yeah, the pandemic kind of hurt the institution.
When such a radical, stuff like that can happen, it's easy for someone to sound like they're saying, "Oh, do your own research," right? But they're not. They're not saying what they're saying is not do your own research. They're saying go to these specific specific sites, these specific groups of people that are saying exactly what I like. Might not be the truth, but it's what I.
Well, it's like a baby with the bathwater kind of argument, right? It's like if science lets you down, well, then all of science must be wrong. It's like,
Yeah,
right? And
it's like an all or nothing thing. It's like there's nuance.
Yeah.
But it's hard. But I think it's
Again, the project is really cool, right?
It's almost a sphere of science communication. Just
Well, it's a failure of the state too. I mean, I'm not going to start like picking. I'm not going to like get involved in this right here and now. But like, I mean, there's a lot of people going outside of their certainty windows on things, right? And that undermines your authority as a scientist. That's what I keep trying to talk about. Whether you're Graham Hancock or the CDC, and you say like, "This is absolutely how this works" or whatever, and you don't have God, there's and you totally kill your cred when you do that. Is the thing, and the fallout can be a real nightmare.
when I said there's no way this Earth could be more dense than the sun, I made the same mistake.
Yeah. It's good. It's good to learn these things. Like, I've really, really changed as a human being about the way I talk about these things over the last 10, 15, 20 years. Like, I used to be one of those people. I had a lot of faith in a lot of things, and I have a fair amount of faith in a lot of things still, but I still always try to keep this little part of my brain that's like, well, maybe it isn't what I'm thinking. Whatever it is. Even if I get in an argument with my wife or something, I gotta keep a little piece of my head open, like, well, maybe she has a point. Maybe she has a point. You know what I mean? Like, she's mostly wrong still, but like, maybe she's got a little bit of a point, you know? And I think you have to be like that with the natural world and trying to understand how mysteries unfold in general. Yeah.
Things we learn things more easily than we
Sure.
back then. So it's kind of hard, like maybe she had faith in that. But now we have tools that show it's something different. And that's kind of like back to Galileo. Whenever he would say he stood on all the shoulders of giants before him, it was because he realized that it took all of that going back and forth because that's what science is.
Yeah. Yeah, there's a huge part of it that's not just doing new experiments. It's like putting together ideas in general. Maybe one of you guys will put together some things that we're like throwing out here and come up with a different way of seeing it, and maybe you'll be right. It'll probably be a miserable life for you if you are right, but that's how it works, and it's actually really magnificent. And there's a lot of bad ideas, but I think that a real argument can be made that bad ideas aren't as scary as we tend to think they are. In fact, we should learn how to argue against them, not to simply run away from them. And the reality of the situation is that most, if you go and you do grad school and you actually become a scientist and all this, you hear a lot of like these horror stories of like, well, we have to be like really careful because like, we have to have this like really rigorous peer review system because people will make up data and they're going to lie about stuff and we got to protect the castle from these people or whatever. But like the reality of the situation is that the good ideas are the ones that work, that people continually refer back to. A very small number of papers gets all of the citations proportionally in terms of science. These garbage ones that nobody can reproduce, that maybe people made it up altogether, they just don't matter because nobody's referencing them anyways. Like, it's just, maybe it's a waste of money and maybe it's fraud and grift, but I mean, the world's full of fraud and grift. I think people get way too hung up on it. bad ideas really aren't as scary, at least these kind of natural world bad ideas. Now, they can maybe be politically weaponized bad ideas, but again, if everybody knew how to think in the first place, then you should be able to argue against a bad idea that's being weaponized against X, Y, and Z people, persons, whatever.
When, like, people in general should be more comfortable with disagreeing or it being wrong.
Yeah, yeah, you should. We got to talk about the things that are difficult and hard. We got to learn how to think around, our way around them, right? We don't have to just accept a bad idea because it's bad or scary. There's probably something wrong with it, is the truth. But you need practice to pull that off. Anyways, I won't keep you guys any longer. Yeah, you got one final thought.
While we should be accepting new ideas, it's also important to hold some degree of strength for the ideas you have because you develop those ideas for a reason and we're following some logic to get there and it's still worth defending. You may be wrong, but there's still some truth in it, and there's probably some truth in the counter argument as well.
Yeah,
They came up with that idea.
you're absolutely right.
There's some evidence they found.
You're right. Yeah, the phrase I hear is like, you need to be open-minded, but not open-minded enough that your brain falls out of your head, right? So it's a fine balance, I guess. And that's, humans don't like nuance, right? Like we want to have, this is the right answer, this is the wrong answer. But the real thing that you guys should, like, hopefully the reason you're even in college is because you want to be one of those people that's able to look at two ideas and be like, I think it's like that, and synthesize a new solution to the problem that nobody's ever thought of before. That's when you're like a fully functional human being. And that's what we all need to be if we want to have a civilization that endures for another 1,000 years. Otherwise, barbarians are at the gates. All right, guys. I'll see you guys. Have a great weekend.